Strange things are afoot at the Circle K.
Ever wondered if there could be another version of you out there, living a completely different life in a universe parallel to our own? From scientists to philosophers to storytellers, parallel universes have fascinated humans for thousands of years. From the implications of quantum mechanics to the vast expanse of cosmological theories, the so-called multiverse changes every aspect of traditional reality. This is Unveiled, and today we're taking a closer look at 10 big questions about parallel universes. Do you need the big questions answered? Are you constantly curious? Then why not subscribe to Unveiled for more clips like this one, and ring the bell for more thought-provoking content. What is a parallel universe? By definition, what we're dealing with here is a theoretical universe similar to our own, but coexisting alongside us. Parallel universes might also be called alternate universes, the implication being that they could be almost entirely the same, but just a little bit different. Or, on the other end of the scale, they're almost entirely different, perhaps with different laws of physics to our own, but still with at least one or a few recognizably similar characteristics. As such, parallel universes are of course incredibly popular concepts in science fiction, mostly because the creative possibilities are pretty much endless. Imagine you're flipping through TV channels, but instead of shows, each channel is an altered reality. Again, some are almost identical to ours, while others can be widely different with alternate histories, different rules of nature, etc. This higher version of the TV guide would never end. The choices available are infinite. Importantly though, it's more than just a cool story trope. According to certain scientific theories, this really could be the structure of reality. Our universe really might be just one of many in an expansive multiverse. For example, in the strange realm of quantum mechanics, the many worlds interpretation says every quantum event could feasibly split this universe into two. Meanwhile, some models of cosmic inflation claim that parallel worlds are possible through the formation of distinct bubble universes as space expands ever outwards.
How big is the universe?
Infinite.
How does quantum mechanics predict parallel universes? Here is where the many worlds interpretation is key. In quantum physics, particles like electrons can exist in multiple states simultaneously. It's a phenomenon called superposition, made famous through Schrödinger's cat, an oft-repeated thought experiment. It states that if you close a cat in a box with a particle of radioactive material and a flask of poison linked to the decay of that particle, then the cat is, in effect, both alive and dead until the box is opened and the state of the particle is observed. One interpretation is that a particle, any particle, is only ever what it is once we view it. One implication, then, is that there could be other states happening all the time outside of what we view, as though behind the scenes of reality. And this is the basis for many worlds. Many worlds models claim that when a quantum particle collapses into a state, instead of discarding all other scenarios, the universe splits into multiple versions. In each new universe, the particle takes on one of its possible states. So two possible outcomes will always create two universes, and so on for every single quantum state, ever. On a higher level, it then figures that every decision and random event should also spawn an entirely new universe with a different outcome and timeline from then on. If you flip a coin, the theory suggests the universe splits into two, one where it lands heads and one where it lands tails, or maybe even three, with one where it bizarrely lands on its side. Apply the same thinking to every single random event in the history of everything, and you get an unfathomably large cosmos with a potentially infinite number of alternate universes, with every possible scenario happening somewhere. While it sounds like science fiction, it's a serious theory that many believe offers an explanation for the peculiar behavior of quantum particles. For some, it eliminates the wave function collapse, the process where particles choose a state when observed. Instead, many worlds suggests that all possible outcomes do happen. It's just that they all happen in completely separate universes. Importantly, while it's a captivating idea, it's also currently deemed unprovable. Like most multiverse theories, we can't interact with the alternate realities that it predicts. But growing numbers do consider it valid for a lot of further research. So watch this space.
Look, I need to know what I stand to win.
Everything.
How's that?
You stand to win everything, call it.
How does cosmic inflation predict a multiverse? Here, we're jumping from the smallest possible quantities to immensely large objects. Cosmic inflation is a theory at the other end of the scale to describe the rapid expansion of the universe as we know it immediately following the Big Bang. It's said that the expansion happened in the first few fractions of a second after the Big Bang moment, at a rate beyond the speed of light. All in all, it's a moderately successful theory and has been included in the standard cosmological model. Inflation does suffer from some issues, though, including that it's unclear where inflation ends. One solution to explain this is the bubble universe theory, otherwise known as eternal inflation. It's another that's only hypothetical at the moment. Broadly, it claims that the cosmic inflation suspected to be at the heart of everything didn't stop everywhere at the same time. Instead, it stops at different times in different regions. And when this happens, it creates closed-off separate structures, aka bubble universes. Our home reality just might exist in one of these bubbles. But it isn't alone, not by a long shot. So the theory goes, if we were to break beyond our bubble, then we should find countless others like it. Although their insides, their laws of physics, rules of time, their nature of reality, etc., would likely all be very different. Outside of these bubbles, inflation continues eternally, implying new bubble realities are constantly being created as well. But for us, detecting bubbles is a serious challenge, primarily due to the inflating space-time that's separating ours from all others. Some researchers wonder if the cosmic microwave background radiation could provide an answer, perhaps giving some kind of indirect evidence of the multiverse via certain patterns or anomalies in the radiation. But as yet, it's another picture of what true reality might look like that hasn't yet been proven.
Einstein says that time is not the same for all of us, but different for each one of us.
Can black holes connect us to a parallel universe? It's no stretch to say there's nothing in the known universe that we know less about than black holes. Yes, they're spectacularly dense regions of space with gravity so strong that nothing, even light, can escape them. True, many of them form from the remnants of massive collapsed stars. And yes, the event horizon is what we term the point of no return, the boundary beyond which our black hole is final. But once passing this point, it's wholly unclear what happens next. There's spaghettification, the somewhat vague and definitely terrifying process of stripping matter back down until it's just a long line of its most fundamental particles. And then, at the heart of a black hole lies its singularity, where gravity is infinitely strong and all the laws of physics break completely. But broadly, that's as far as currently confirmed mainstream science goes. Nevertheless, in the significant gaps of black hole science, many have mused about potential routes to a multiverse. For some, the singularity could be crucial. At this most unknowable of points, it's before been suggested that it could actually connect to other points in space, perhaps with the black hole's theoretical opposite, a white hole, at the other end of the connection. But more than that, if we accept there being some form of hyperspace in whichever guise, then the singularity might just as well bridge to other universes in a multiverse. It's an idea in part inspired by what's known as the information paradox, which questions where information goes after entering a black hole.
There ought to be something very special about the boundary conditions of the universe. And what can be more special than that there is no boundary?
Are wormholes pathways to a multiverse? Although not the same as black holes or potential black hole-white hole tunnels, wormholes do often come up in similar conversations, and understandably so. Wormholes, also known as Einstein-Rosen bridges, are theoretical passages through spacetime. They're certainly considered to be physically possible, and are believed to represent a potential method for creating shortcuts between distant parts of our universe. It could be that wormholes actually represent the very best chance we have of breaking the local speed of light, and thereby managing to achieve intergalactic space travel. But in terms of parallel universes, it again makes just as much sense, particularly if you accept the eternal inflation-style multiverse, that a wormhole could punch through reality to link separate universes as well. Naturally, there is a major problem with the plan, however, as we've never actually observed a wormhole, and we can't seem to make one. Were one to appear and remain stable, it's thought likely that it would require exotic matter with negative energy to operate correctly, both of which we have very little understanding of. The more optimistic researchers, though, tend to point to the monumental jumps in knowledge our species has made in the past as a reason to believe that wormholes might one day be realized. It wasn't so long ago that we thought the sun circled the Earth, or that we were wholly unaware of other galaxies in the wider universe. So perhaps it's not quite so far-fetched to believe that at some point in the future, wormholes won't only be known, they'll be common.
It's infinitely complex. They have access to infinite time and space, but they're not bound by anything. They can't find a specific place in time. They can't communicate. That's why I'm here. I'm gonna find a way to tell Murph, just like I found this moment.
How does string theory relate? As one of the leading contenders toward a theory of everything, could it be that string theory holds the solution for parallel worlds? In short, it aims to unite nature's 4 fundamental forces into a single cohesive model. These are the strong and weak nuclear, electromagnetic, and gravitational forces. Gravity is the weakest of all, which means that it's also the most difficult to incorporate into quantum mechanics. Which is why a working model of quantum gravity doubles up as all that's still required for a theory of everything to work. So how does string theory propose to solve the riddle? It says that the cosmos's most basic building blocks aren't exactly particles as we'd usually imagine them. Instead, they're tiny vibrating strings. At the smallest level, according to string theory, we don't have point-like particles, but instead one-dimensional strings. And it's the frequencies at which they vibrate which determines the particles and forces that we observe at our higher macro level. One of string theory's most intriguing qualities, however, is its requirement for extra-spatial dimensions, beyond the 3 of space and the 1 of time that we're all familiar with. Even at its most conservative, it says there could be up to 10 or 11 in total. As to where they are, it's said that they're compactified, curled up, and basically much smaller than we can detect or comprehend. And here's where various multiverse scenarios perhaps naturally arise. Some claim that it's in how these extra dimensions are compactified that could ultimately result in different types of universe, with each compactification corresponding to different rules of physics. And before long, the wider structure creates a vast multiversal landscape, commonly referred to as the string landscape. Now it's as though our reality is but one specific stitch on this new and rich tapestry of strings. And what's more, it could be that string theory has a role specifically to play in the bubble multiverse idea as well, with all of its extra dimensions wielding unknown influence over the processes of eternal inflation.
Groupings of tiny energy waves bound together.
By what?
Forces of attraction strong enough to convince us that matter is solid. Stop my body passing through yours.
What are brain worlds? To another offshoot of string theory, as brain worlds are another potential answer to the puzzle of the multiverse. Here the word brain is short for membrane. And in this context, membranes are multi-dimensional objects existing in a higher dimensional space. Some varieties of string theory lead us here, modeling our universe as a brain, a 3-dimensional brain, embedded in a much broader structure known as the bulk. Now it's the bulk specifically that proponents claim has more than our 4 familiar dimensions, and again, potentially as many as 10 or 11. So while we're confined to our home brain, there may be other brains existing alongside ours, each with the potential to harbor universes, perhaps even with the potential to host multiverses of their own, of say, the bubble universe variety. With brain cosmology, there's the potential to really up the ante. In some ways similar to the lower-level bubbles of eternal inflation, it could then be that these brains are right next to each other in the bulk and yet entirely inaccessible to us. It could be that they never meet or link or merge, although there are some theories that they again may wield indirect influence over one another. It's been suggested, for instance, that fundamental phenomena such as gravity could somehow leak throughout the bulk, permeating our membrane at least, and thereby dictating what is and isn't possible here. At the same time, there is discussion surrounding the follow-on question of what would happen if brains were to collide. Such collisions may give rise to new universes or alter existing ones. Some cosmologists go as far as to suggest the Big Bang might have been a brain collision, spawning our realm alongside the untold others that could also be out there. This is still a topic of debate, and various, perhaps less radical ideas have been proposed to explain the Big Bang. There's arguably no strong evidence for any position, however, with the prospect of colliding brains therefore just as valid as any other.
I have to show you that our friend has proven that time indeed has a beginning. Not only that, how the universe was born, and how it will end. Bang! Crunch!
Do we have direct evidence for the multiverse in any form? Given all of the ideas that we've discussed, it's a kicker, but it's important. As things stand, we don't have any direct evidence that parallel universes exist. The multiverse and parallel worlds are much more theory than fact, but it's also a field of research that's really still in its infancy. As we've already seen, finding evidence for parallel universes is particularly challenging. The simple nature of alternate realities makes them inherently difficult to prove. By definition, they exist independently from one another, and therefore independently of literally everything we know. We're living, working, thinking, and existing in a separate and self-contained world, as is every other world that may or may not be out there. It's unclear whether it would ever even be possible for contact between parallel worlds to ever take place. Even observation of them might be a step that's inevitably too far. All of the above applies for almost every conceivable parallel universe model, from bubbles to brains, quantum splits to pulsating strings. Nevertheless, many of the leading theories in support of parallel universes are based on strong scientific principles with intriguing possibilities. Optimists within the field may well hope that unknown future advancements in science and technology will one day make it possible to identify evidence. What's your opinion? Let us know in the comments.
So what next?
Prove it.
How do parallel universes affect our understanding of the cosmos? Philosophically, even contemplating parallel worlds requires a major shift in thinking. The concept challenges long-held, deeply entrenched views about who and what we are. Our traditional view of reality comprises space, time, matter, and energy, all contained within our universe. But casting our net wider out into a multiverse suggests that for all the unknowns we already have, we've only ever been observing a tiny, tiny pocket of existence as a whole. In almost all proposed forms, an alternate reality could have different physical laws, different physical constants, and multiple extra dimensions. Our safe and comfortable 3D plus time just doesn't cut it anymore, and the impact is profound. One of the most famous potential applications of the multiverse is that in some versions, it could mean that there are multiple versions of you somewhere out there. So how should we feel about that? Would the multiverse lessen the importance of our own lives? Or does it matter? Could it be argued that parallel worlds ultimately prove that free will is an illusion? Or are we still in control of what some may call our destinies? Looking deeper into parallel universes, it challenges any assumption towards us living in a single objective reality. Instead, it thrusts us into an indescribably complex, multi-layered existence. And that's pretty exciting. Or maybe it's just quite scary.
It's a probability storm. Every choice you could make existing all at once.
What's he saying?
You're inside Schrodinger's box, and you're the cat.
That doesn't make sense.
What does the future hold for parallel universe research? To put it mildly, there is a lot that's in the pipeline. In the field of quantum mechanics, we're already seeing major advancements in quantum computing, which could enable us to control the subatomic realm like never before. In astronomy, our technology is constantly improving, with the James Webb Space Telescope recently becoming our single greatest and most powerful piece of observational equipment. It and its successors will provide unparalleled world of the universe and perhaps beyond for decades to come. Meanwhile, we have a growing network of particle accelerators like the Large Hadron Collider, which are continually revealing new bits of information about nature's most fundamental processes. Even higher energy colliders are reportedly coming, which could probe even deeper, potentially taking us much closer to major advances in string theory or the brain world. What's clear is that right now, science is only just getting started. While science fiction has its fun dissecting all that could happen if parallel universes were real, science fact is busy chipping away at the concept in real life. But regardless of the specific findings, that can only be a good thing.
Now it's your turn to deal with the consequences of your achievement.
Parallel universes push the boundaries of modern science, encouraging us all to think outside the box. Quantum mechanics, cosmic inflation, string theory, and brain cosmology all incorporate it, in general, to potentially explain certain phenomenon which might otherwise be unexplainable. But in the meantime, the entire endeavor encourages interdisciplinary collaborative research. Thinking about parallel worlds is to blend physics, cosmology, math, and philosophy in a wholly fresh and unique way. It's big picture thinking, but on the grandest scale imaginable. And along the way, multiverse research is sure to trigger countless breakthroughs. But perhaps more than anything else, it's a line of thought that humbles us. Even the fact that parallel universes exist as an idea already represents a dramatic alteration to our perception of reality. If they ever were to be proven, then humankind will have truly entered into an all-new age.
Stephen? I'm glad I fell into your universe.
So am I, kid. So am I.
What do you think? Is there anything we missed? Let us know in the comments. Check out these other clips from Unveiled, and make sure you subscribe and ring the bell for our latest content.